Welcome to all. Myself Rajalakshmi R, Assistant Professor, Hindustan College of Engineering and Technology. I am going to present the topic orthogonal basis. First, we know the definition about orthogonal. Let us consider the vectors x, y from the inner product space V. If the inner product x, y is 0, then both x and y are perpendicular. So, we can say that the two vectors are orthogonal. Formally, we are defining let V be an inner product space and let x, y belongs to V. X is said to be orthogonal to y if inner product of x, y equal to 0. Let us now discuss through an example. Check whether the vectors u and v are orthogonal or not. The solution. To find the inner product of the two vectors, inner product of u dot v equal to 1 into minus 1 plus 1 into minus 1 plus 2 into 1. Let us multiply the corresponding elements of the two vectors and add the values, then we get inner product of u comma v as 0. So we can say that the two vectors are orthogonal vectors. Next, orthogonal set. Let S be any set containing S equal to V1, V2 up to etc. Vn. Then when we can say S is said to be orthogonal set if any two vectors of the set is an orthogonal vectors. Let us explain through an example. Let us consider x, y, z belongs to R power 3. We need to find the inner product of any two. Here I am taking inner product of x, y equal to 1 into 0 plus 0 into minus 1 plus 2 into 0. So multiply that the corresponding elements and adding we get inner product of x, y as 0. Therefore, x is orthogonal to y. In a similar way, inner product of y, z and inner product of x, z as 0. Next, orthonormal. A set S is said to be orthonormal. It should satisfy two conditions. First one, S should be orthogonal and the next norm x is equal to 1 for all x belongs to x. The example, here we take S equal to 1, 0, 0, 0, 1, 0 and 0, 0, 1 is an orthogonal set. Taking norm of 1, 0, 0 equal, which gives the values as 1. In a similar way, norm of 0, 1, 0 equal to 1 and the norm of 0, 0, 1 as 1. Therefore, S is an orthonormal set. Next, the definition about orthogonal basis and orthonormal basis. Let V be an inner product space when we can say S is orthogonal basis if any two vectors are orthogonal. In a similar way, the orthonormal basis is let V be an inner product space when we can say S of V is an orthonormal basis for V. It should satisfy the vectors in the basis are mutually orthogonal and their norm is 1. Next, the definition about Gram-Smith orthogonalization process. The process of constructing an orthogonal basis from the ordinary basis through Gram-Smith orthogonalization process, which can be constructed from the following formula. The formula is W1 is equal to V1, W2 is equal to V2 minus inner product of V2, W divided by inner product of W1, W1 into W1 and next W3 is equal to V3 minus inner product of V3 W1 divided by inner product of W1 W1 into W1 minus inner product of V3 W2 divided by inner product of W2 W2 into W2 and so on up to the series Wn. Thank you.